So Assalamualaikum and a very good day. So today we are from group 11. For assignment Industrial Control Electronic, we're going to talk about crane shipping system. Sorry, my name is Muhammad Azmi Bezamri. My metric number is 181923. My group member is Muhammad Shawal Hafzat. Metric number 18183871 and Said Uchai 183655. So our objective today is we're going to understand how the crane shipping system develop. How does a crane shipping system load from a ship to its shore? So next, okay, basically what is crane shipping system? Okay, a crane shipping system is basically a type of a large dockside gantry crane that is found at a container terminal for unloading and loading intermodal container from container ship. It consists of a supporting framework that can traverse the lengthful of a quay or yard on a roll track. So it is equipped with a specialized handling tool called a spreader. The spreader can be lowered on top of container and locks onto the container for locking points using a twist lock mechanism. So this it doesn't use a hook, but it uses a twist lock mechanism. And cranes can normally transport a single container at once, but some new cranes can transport 2 to 4 of 20-foot container at once. Next, okay, for this assignment we go for a shipping crane system. We're going to choose a gantry crane. Okay, what is a gantry crane? Gantry crane is a type of crane that is built atop of a gantry, which structure is used to straddle an object or workspace. So it is used at a shipping bay to load containers on and off a container ship. The terms gantry crane and overhead cranes are often used interchangeably, so they are quite different. But gantry crane overhead crane is kind of the same, but only a slight of difference. There are many types of gantry cranes such as ship-to-shore gantry crane, full gantry crane, rubber gantry crane, and also workstation gantry crane. Okay, this is an example of a ship-to-shore gantry crane. As you can see, it has the structure is like that. It can move. The straddle mechanism can move the container from the ship to the shore. We're going to use a wire. It's going to move at the platform and put it at the shore. Okay, there are some elements for the ship-to-shore gantry crane. First of it is the lateral movement system. Next is the vertical frame and braces. Then the crane boom, the hook, the operating cabin, and also the storage equipment. This is the some elements in the ship-to-shore gantry crane. Okay, let's move to the motor for the gantry crane. So, one of the industrial motor that used in a shipping crane is the DC series motor. Okay, DC series motor, it converts electrical energy to the mechanical energy. The key component of a DC series motor are at the armature, the stator, the armature or the rotor, the stator, commutator, field windings, axle, and the brushes. The rotor is comprised of the armature with windings on the core connected to the commutator. The rotor has a central axle about which the rotor rotates. The stator is made up of 2 or more electromagnetic pole pieces. So this is the motor that is used in the shipping crane, that is the DC series motor. So next we're going to show how to control the speed of the motor. In DC series motor, a linear relationship exists between the amount of torque produced. The speed of motor can be controlled by varying the voltage across a motor. So, to increase and decrease the motor, to increase the speed of motor, we have to decrease the field current by placing a small resistor in parallel to the winding of the armature. Then, the decrease in current will result in lowering of magnetic flux and counter EMF. So now I'm going to tell you how to decrease the speed of motor. To decrease the speed of motor, we're going to use an external series resistor along with the field windings and also the armature. Okay, next, the principle of operation. Okay. The principle of operation of a DC series motor, an external voltage source is applied across the series configuration and field winding and armature. So when the motor start up, the voltage source connected to the motor, the voltage source will be connected to the motor and withdraws a huge amount of current. The large current will go through the winding gears, then will produce a strong magnetic field. This strong magnetic field will provide a high torque to the armature shaft, thus will invoking the spinning action of the armature. Thus the series motors, once when it start, it will offer a maximum speed and torque, but gradually will increase in speed. Its torque will come down, thus will reduce its current. Okay, due to the high torque provided to the armature, the load on the shaft is set to rotate initially. So this is the principal operation of the DC series motor. Okay, thank you.
Hello everyone, my name is Seiyu Chai and my metric number is 183655. So now I am going to explain to you all about the model presentation of the gantry crane system. So the image on the left is actually showing the dynamic model of the gantry crane system, where it is actually consistent of a cart moving in horizontal direction, while a mastless pendulum is connected to the cart and hoists the payload. The table on the right is actually containing the parameters of the gantry crane. As you can see, the first 5 variables are actually the manipulated variables related in this gantry crane system, while the rest are actually the constant variables that have been assumed to be constant throughout the system, throughout the experiment. And then a number of assumptions have actually been made in order to simplify the system. And as a result, applying those assumptions, the nonlinear dynamic equation systems appear to be these 2 lines of figures. And in my case, I also consider an electric motor in the gantry crane. Therefore, the linear force F, which was supposed to be represented by F, here has been replaced by this expression. And after that, the rest are actually the state space representation. And as you can see, like I mentioned, there are actually 4 variables required in this gantry crane system, which are cart position, cart velocity, pendulum angular displacement, and pendulum angular velocity. And also, these 4 are the matrices for the state space representation. And then now, when I try to implement PID controller into the gantry crane system, the overall block diagram will be looking like more or less like this. So as you can see, this is the crane system, and then this whole block is actually the PID controller. And now is the simulation part. And before that, I will need to define those values of parameters in the tables before, so that I can obtain the transfer function of the system and the simulation in MATLAB. So if you understand, based on the matrices A, B, C, D just now, if I try to convert state space into transfer function, now I will get something like this. And then after I put those parameter values into this transfer function, and the corresponding function will be looking like this. So for this system, actually the desired criterion of the control design are suppose that the trolley can track the reference input, while the sway of the pendulum is quickly dampened. And also the input voltage should not exceed the maximum value, its maximum value. So therefore, in order to deal with this, I prefer Ziegler-Nichols method in this case, in order to help me to develop, help me to obtain or develop certain PID, certain values of PID, so that I can get the best parameters of design. So as you can see, the table on the top is actually showing the ways proposed by this Ziegler-Nichols method for you to get the best values of value of PID for different types of controller. But in this case, the type of controller I am using is PID, so I will be using the last row of formula throughout the simulation, throughout the experiment, and also the simulation. And then so like I said before, to achieve the best parameters of design, different values of control gains are used, which are obtained from this method, and the corresponding responses are then evaluated. After that, the best values of control gains are chosen, and the response of the system and input voltage are then determined. So if you can see, the table below are actually the results from my for the results that I have got using Ziegler-Nichols method. So in this case, I employ 4 tuning attempts, and the first try of PID tuning via this method is actually giving me Kp is equal to 4.160, and the rest and so on. And now is the simulation part. So these whole things are actually the lines of coding of transfer functions for those 4 gains, 4 different sets of values of gains that I have obtained from Ziegler-Nichols method that you could see just now from the table. So assuming the unit step for the reference input, the output signal of the gantry crane has been obtained. So as you can see, the first try of PID tuning via the Ziegler-Nichols method has given me a reasonable time response of gantry crane, while it almost eliminates the error at steady state. So the first try is actually represented by the blue curve. However, the overshoot and oscillations of the output is still high. Thus, for achieving better response, I tried another 3 times of tuning process, keep on, and then as it is obvious to see, after those steps of tuning processes, the desired result is obtained. So the final values of those gains that I got and implement into the system, and the last curve that I got is the purple curve. You can see that the system response is better than my first attempt when I try using the first estimation control gains. And that's all from me.
Okay, we will continue our presentation about shunt DC motor, that the other industry motor that we use in the gathering crane. Okay, shunt DC motor operate on direct current. The field winding and armature are connected in a parallel combination. In electrical terminology, a parallel combination is known as a shunt. This type of motor is shunt 1 DC motor, and the type of winding is called a shunt winding. Okay, for the connection, the shunt DC motor have a starter that field winding, a rotor also known as a armature, and a commutator that used to flow the current from the starter to the rotor. Okay, next is about the principle of the operation. When electric voltage is supplied to the shunt DC motor, due to high resistance of the shunt winding, it draw very low current. It means the high resistance affect the current below. Okay, the high number of turn of the shunt winding help in generating a strong magnetic field. It means if we want to increase the magnetic field, we can increase the turn of the shunt winding. The armature draw high current, also generating a high magnetic field. The motor start rotating as the magnetic field of the armature and shunt winding interact. As the magnetic field grows strong, rotational torque will increase, thus resulting in an increasing of rotational speed of the motor. Okay, next is about motor speed controller that we use to control the speed. Okay, the speed of DC shunt motor can control by using two ways, which by varying the current supplied to the rotor and by varying the current supplied to the starter. As the voltage around the rotor and starter is the same, the speed of the motor can be controlled by controlling the current through the starter or rotor. The current through the starter and rotor branch can be controlled by varying their resistance or by using a silicon controlled rectifier. The resistance can be increased in the shunt winding and armature branch by placing a rheostat in series. As an armature handles much higher current than the field winding, so the rheostat for controlling current in the armature branch is quite large. This is why having the current controlling rheostat in the field winding is generally preferred. Okay, next is about braking, dynamic braking. In case of DC shunt motor, armature is disconnected from the supply and rheostat is connected across it. And a rheostat is connected across it. Okay, the field winding is left connected across the supply. Obviously, now armature is driven by the inertia and hence machine start acting as a generator. Thus, the machine will now feed the current to the connected rheostat and heat will dissipate. Braking effect is controlled by varying the resistance connected across the armature. Okay, lastly about plugging. Plugging okay, armature connection are reverse and hence motor tend to run in opposite direction. Due to the reverse of the armature terminal, apply voltage and back EMF start acting in the same direction and hence the total armature current increases. To limit this armature current, a variable resistor is connected across the armature. This is similar for both series and shunt wand method. Okay, this is a PLC, programmable logic controller for the gantry crane. Okay, for the gantry crane, we need the 4 buttons that up, down, left and right. Up and down for the vertical movement and left and right for the horizontal movement. So we also add the button off and button stop to switch on and switch off the gantry crane. Okay, the conclusion. A crane shipping, or basically it is called a container crane, is a type of large dockside gantry crane found at container terminal for uploading and loading intermodal container from container ship. The example of industrial motor that use crane shipping system are shunt DC motor and DC series motor. About the PLC. PLC is a microprocessor based controller designed for industrial control. In PLC, programming is implemented in a graphical programming language known as a ladder diagram. A PID turning procedure has been developed to control of a gantry crane. Hence, Rigel-Nichols method has been used to initiate controller gain, and then a turning procedure has been developed to obtain better result. Finally, numerical simulation have been performed to show the capable of the turning procedure to control of the gantry crane. Okay, thank you.